Good afternoon and welcome. I'm Brent Donaldson, Executive Editor for Modern Machine Shop. Today's webinar, brought to you by Machine Metrics, will explore how automated production monitoring solutions capture accurate, real-time machine data and automate data flow to other business types, helping manufacturers achieve greater visibility and efficiency. In today's session, we'll learn about the benefits of automated production monitoring powered by real-time machine data, reducing the burden on frontline workers by eliminating needless manual tasks, and machine data to inform business systems and people, not the other way around. Today's presenter is Bill Byther, CEO and co-founder of Machine Metrics. Since launching the company in 2014 to bring visibility and predictability to the manufacturing factory floor, hundreds of manufacturers have connected thousands of machines to Machine Metrics across global factories. We also have with us today Jordan Schaefer, manager of the Advanced Manufacturing Engineering team at Silencer Co., who's been working with Machine Metrics for a few years to automate their production monitoring. Jordan will join us in a bit later to share what his company has been able to accomplish with the platform. Please note, listeners, that if you have any questions at any time during the presentation, you can type them into the question panel on the right side of your screen, and we will do our best to answer them at the end. Also note that this webinar is being recorded, and you will receive a link to that recording via email after we've finished. So with that, I will turn it over to Bill.
Great, thank you, Brent, and thanks for everyone's time this afternoon. Just real quickly about myself. So Bill Byther, I am the co-founder and CEO of Machine Metrics, and I started this company a few years ago, really to address this problem that we're seeing in manufacturing today. First thing I really want to point out is that today's manufacturers are really under an incredible amount of pressure, especially with the supply chain issues that we're seeing. There's really a need to produce at higher capacity. We also have a real shortage of skilled workers, and this is driving an even greater need for efficiency and an inspiring place to work and employee satisfaction. And then finally, the heightened competition is really requires delivering high quality products at lower margins. And this number here is something that we've been producing for a few years since we've connected to thousands of different pieces of manufacturing equipment. And it really represents that the industry itself has a long way to go. We see that the average utilization rate is just 28%. And it's really what's inspired me to start the company. There's just a huge opportunity for improvement. So let's take a look at kind of where we are today. So today, we're undergoing a pretty significant transformation from manual, what we'll call like lean systems, to connected systems that really rely less on human interaction. At least that's the goal, right? So most factories today, the issue is most factories are disconnected. So their machines, the automated equipment is disconnected from the people who operate them. There's not a lot of great visibility. And then the systems that manage day-to-day operations are not well connected to the machines and the people. So this results in a lot of manual effort to keep systems running. And it's these people that's really required to keep these systems going. And you can see here, just from the data from posted recently, there's an incredible amount of job openings that are just not being filled. There's really this lack of visibility in your production requires more people, and we can't hire those people to really fill in those roles. So this automation and connecting these systems become critically important. So the industrial IoT was really designed to mitigate this, to connect machines to the people and to the systems. But we've seen time and time again that these initiatives often fail. So Cisco, there was a study done recently where they're saying 60% of IoT initiatives fail. There's other studies that actually show that this goes up to 80%. And the reason really is that, especially in manufacturing, when you're connecting various pieces of equipment, each machine might have a different way to get data from it and requires domain experts to really understand. And this is required that there's just a lot of system integration, a lot of outside help that's required, and it often takes years to be able to pull a system together that really provides value. And that's the problem that we see today with some of these current systems. So back to like where we're trying to go. Like the goal today, like I said, is really to connect these systems. What we're seeing is that there's an awful lot of manual data entry. So most of you, probably on this call have worked with an ERP or MES system, and pretty much the pattern is at the end of every shift, an operator has to go and enter data in manually. How many parts were produced, what work order, what operation, and this data is then compiled and presented in reports, maybe at the end of the day, maybe at the end of the week. The data just isn't actionable, and often it's not accurate. So these MES systems, or manufacturing execution systems, really are designed to provide that visibility into production, to quality, maintenance, and inventory. And they really do require that data in real time to be effective. And they're just not getting it. So this really leaves the frontline worker or the operator to be responsible for keeping these systems up to date. And frankly, they'd rather be spending time making sure that their equipment's running, programming the machines, optimizing processes. That's what they signed up for. But so much of their time is spent in typing data, interacting with other software systems. So we aim to fix that. And really, it is time for that change. So Machine Metrics is manufacturing's industrial data platform for machines. It's really a domain-changing product that's at the forefront of this transformation. So instead of frontline workers driving machines and systems, really it's that machine data and insights from that data that's driving these people and other systems. Decisions can be made in real time, and these frontline workers are given relevant information to help make those decisions. And there are other systems like maintenance, quality, production systems are connected in real time. So the operator's job is to keep the machine running, and the machine's job in the system is communicating all throughout this whole, what you might hear of as the digital thread. So just a little bit about Machine Metrics. I'll try not to spend too much time, but it is my webinar, so you'll hear a fair amount about it. So we've been around for a few years. We have customers worldwide, hundreds of customers connected to thousands of machines. And really, we're focused in the discrete manufacturing vertical. So, automotive companies, aerospace, heavy industry, med device, they're all customers of ours. And we've also connected to many different types of machines. So like I said before, it's really important to have that domain expertise to understand how to get data from machines. And we've made that really, really easy. So most of this is pretty plug and play. Some light configuration, but getting value from that data can be really quick. So we started in really CNC machining, so lathes, mills, grinding, but have expanded into other types of equipment, metal fabrication, welding, plastic injection molding, and so on. So the way it works is that we have an edge device, this green box here, that can be installed either inside the electrical cabinet of a machine, or even more commonly, it's connected to a network of machines. And this data is pulled directly from the machine's control. But we can also pull data from external sensors. This can be used for a legacy machine, or for a machine where you want to add, say, additional vibration sensors, humidity, temperature. We support a platform called IFM and IO-Link sensors to make that really easy. So with that connectivity, really, it's important that you support standard industrial protocols. So there's a few standards out there, but you kind of have to go deeper because, in particular, in the CNC space, you have custom controls that require different ways to access the data, and that's something that you get built right into the edge device. Is this software that connects to those controls. This data is transformed automatically to a unified data structure so that you can run analytics across all the different various types of machines and then take action on that through our workflows. So once that data is streamed into the Machine Metrics site, we are a cloud platform. It's accessible via APIs and queries, but also, so you think of it as like a cloud-based historian. All the data is there, the ability to be reported on, and we have applications built on top of that. And then for taking action on that data, workflows are really important. So being able to easily configure workflows without writing code that will trigger based on machine conditions and production activities. This can initiate notifications or integration into other systems. And then finally, the important piece of the platform is to be able to connect to other systems. So connecting to your BI systems, such as Power BI, so workflow maintenance software, so we connect to CMMS maintenance systems, and a wide variety of ERP and MES systems. So with that connectivity with a platform, we see a few core solutions. One being condition monitoring. So what this enables you to do is really to monitor the health of your machine and take action when certain conditions occur. So being able to visualize your machine data, understanding your machine conditions, your alarms, the wear of a cutting tool, and then to be able to take action when certain thresholds are exceeded or certain alarms occur. So that really puts that data in front of the person who needs to take action on it and really connects that. So as soon as a condition occurs, action can be taken, or based on the pattern of the data, you can at times anticipate when a problem might occur through these machine conditions. But what we'll be talking about today really is getting deeper into production monitoring. So many of you, this is Modern Machine Shop, operate or involved in a machine shop, running CNC machines, and monitoring the production of your equipment is often the thing that you really want to be tied into, and that's what's been really difficult. It's required a lot of manual entry. So the first thing is really making sure that this data is coming from the machine, and only when necessary should the operator have to augment that machine data. And I'll be showing you in a few minutes what that really looks like. But once that data is captured from the machine and you have the machine data, you know when the machine is running, parts that are produced, how many, and also importantly, what operation is running that machine. You have all that you need to monitor your production, to basically configure your data so it's ready to be synchronized to your MES system. And that's part of this flow of data, really positioning it in a way that makes a lot of sense that can be then synchronized to your MES or ERP. Other aspects that can be really important is understanding your downtime and changeovers. This can come from machine data, but sometimes we do. If you want to really dive deep into that, you might need some information from the operators, from the frontline workers, to do that. And finally, like a very common use of this data is to understand your capacity. So where should we be sending our new work? Are these cells of machines, are they being utilized to their fullest capacity? Or should we buy new equipment? And this information, which is really basic, just how much is this machine running, can really help you, justify these capital equipment purchases. And then really the kind of holy grail here is be able to automate these manual tasks with workflows. So being able to communicate from to enhance this communication from the operator to the supervisors to the back office workers. Making that easy is really important. So with that said, what I'd like to do is spend a few minutes with Jordan, who we've been working with for a few years at Silencer Co. And Jordan can give you basically a few stories about how he's leveraged machine data to improve their operations, to automate their production, and then and after that, I can dive into a real demo. So with that, Jordan, I will hand this off to you.
Bill, thanks. Happy to be able to join it, and thank you for letting me share our story with Machine Metrics. And I figure I'll speak to how things used to be and how things are, because I kind of assume on this webinar that's the situation most folks are in. Say about 5 years ago, I think it's been 5 years now, we've been working with Machine Metrics. Before Machine Metrics, our data was very manually captured, and honestly, we didn't trust it. It was only true at the time it was captured with the stopwatch of, whatever resource, whether that was a manufacturing engineer out on the floor conducting time studies, or, maybe the shop manager or cell lead was saying, hey, we're not able to hit this demand. We need to, times are off, whatever. So we go take these time studies, use those to create some sort of average daily rate to plan around, and never achieve them, right? We'd either be ahead or behind, but it was never real time. It was never accurate. Any misses that we had, we were really just trying to be reactive and correct post mortem, right? Like, hey, we missed our plan versus actual goal by 20 parts yesterday. Well, do we know why? Well, not really, but maybe we think it was this. So let's try to do something. But we didn't really have actionable data. Well, we didn't have data at all, and we had very little to take action on other than, hey, we're missing. Let's try to figure out why and dedicate, some heavy resources to trying to figure that out. So that led us to want to get better data, and that's when we came across Machine Metrics. We obviously have partnered with them and are running that product in our shop. And we're at a point now where we're seeing real-time data. We're capturing downtime events that are coming off of the machines without any sort of operator interaction. The operators are free to really do their jobs, which is to keep the machines running, ensure quality parts are being built, and we're getting the data in real time. So we went from this kind of lag reactive state where we didn't really have data we could trust. We weren't planning to really utilize our capacity at its best, to seeing real-time utilization that our planning folks use to create a plan that we can achieve. And then if we're missing, right, we're seeing these downtime events and reasons. And on the engineering side, that's all actionable data. The other nice thing is, if needed, the operator can provide even more information in those downtime events, so we can really dive deep. And the operators have come to love the system. At first, I think this is a fear everyone may have. We certainly had it when we installed Machine Metrics and networked all our machines. Those Cat5 lines we dropped, the operators nicknamed tattle wires. But pretty quickly they started seeing the value, right? We're seeing all this downtime for, let's say, hey, we're having a hard time breaking chips in this machine. We're constantly in there pulling them out with pliers. Okay, well, now we're seeing how frequently that's happening. So we've got programmers changing tool paths, getting new cutters, new inserts with a better chip breaker, whatever it may be. We're taking action to solve that. And those operators are able to watch their plan versus actual and their OEE numbers climb because we have actionable data and we can be proactive about it. We can solve it real time. One quick example that comes to mind recently is, we had a machine and a part we were running on it, and we're looking at its OEE and just, man, this isn't a hard part. Why is OEE so low? What's going on? We're in like the 50%. And we dig into that and we find out that there's a ton of operator intervention. There's lots of manual interaction, so much so that they've added an MO to the code so they can get in there and clear some chips and then manually remove the part from the machine. With that data, we're able to really dig in and solve the chip issue, get great tool life off our inserts. And, we can look at that data and see the direct impact immediately, within monitoring it over a week. We can watch OEE climb, watch utilization climb. And that led us to saying, okay, now we've solved some of this problem. We don't have as much operator intervention to clear chips. We still have an operator there having to manually remove parts. So how do we make this better? How do we keep going down this path of, right, we automated our data collection. What's next? So we added a robot to that machine so that it can unload the parts, which again requires even less operator interaction, so they can be more efficient with their time. They're really just doing quality checks and loading a fresh bar when we run out. And, we went from 50% before taking action to in the high 60s, low 70s after solving some problems, went up into the high 80s when we added the robot. And we've now leveraged that even further, looking at those downtime events. Now we see, hey, we're having downtime every time we have to change a bar. So now we've got a bar loader on that machine, and we're consistently in the high 90s on OEE, and that's all because we're capturing real-time data and we're able to take action off of it. Other great examples for our shop have been making accurate plans that we can actually achieve, and when we miss, being able to know that there's something we can do about it, right? In the past, we'd miss and we'd think, well, maybe that wasn't a real expectation. When was the last time we actually timed that process? Probably 2 years ago when it was brand new. So no big deal. Now we know that our goals are realistic and we should be able to achieve them. And if we're not, it really creates a sense of urgency within the shop to solve those issues and to really attack them and be very proactive about, hey, we're starting to get behind. What can we do? How can we flex to support this? And that comes through that automated data capture. I mean, I think of, if we were to try to do that without this, we'd need, a team of engineers or techs on the floor just with stopwatches. And what would the cost of that be versus the impact? So this has been, for us, a very valuable tool. We're leveraging, and I'm sure Bill will get to this in a little bit, but they have a feature called Auto Job Dispatch, where the machine metrics is watching what programs are running on the control. It can automatically start those jobs for us and track them. Again, just another step forward where we have less need for operator interaction with the system, and that frees the operator up to be more focused on their critical tasks. So that's something we're very excited about, and we're moving forward with. Next steps for us, we'd really like to move forward with some integrations into our ERP, again, just to leverage the technology and try to automate everywhere we can to increase efficiency, right? Like I'm sure all of you, every machine shop, labor is hard to come by right now. So we need to become more efficient and utilize our heads better. And this has been a great tool in our toolkit to help us get there.
Cool. Thanks, Jordan. I really appreciate those real stories. Yeah. So what I'd like to do now is show a demonstration of the product in action. So here's you should be able to see my screen here. I think it's coming up. So what what you have here is the main interface to machine metrics, which is this list of machines. And it's kind of the launching off point. So it gives you that real-time view into each of your machines, the current status, and then also what that machine is producing for the current operation, and then some metrics around it. And it's completely configurable, so you can show utilization metrics, parts. You can look at different periods of time, and then save those views. But what I really want to hone in on is the data that we're actually getting to really focus on your production monitoring. And what I have here in these 4 machines, I want you to take a look at this 3-axis mill. So this here, it's running this operation called MM2, and I want to go into the sort of the data that we're getting from it. So this is a FANUC-based control machine. And by connecting that machine, we're automatically getting a lot of data items. So these are sort of the standard items. So you can see we're getting the G-code block, the feed rates, the overrides, programs, any alarms that are coming through. And I want to draw your attention to some information here. So we're able to pull from that machine not only the status of the machine, the part count, but also the operation, so the program name. And often you can get that right from this program name, but sometimes it's inside of the header file of the program that's sent to the machine. And so we provide tools to be able to pull this out of the header file. So if you have, for example, the first comment, or if it's labeled something like a part number XYZ, we have tools to be able to pull that out, and that is the operation that's actually created in machine metrics without that operator input. So if we go into this a little bit more, we also have a diagnostic view, and this is interesting in that you can see this data in real time. So here is for example, you can choose any of these data items, and you can look in back in time to see what's happened on that machine, and that's really important to see if there's an issue, for example, with like a machine crash, or maybe an operator edited a program, and you can actually see that here. But going back to this list, what I wanted to show is that what happens when you have a new program that's running. So I have here, this is for a lot of you, this is going to look familiar. It's actually a CNC control. It's actually a simulator. But what I'm going to do here is actually stop this cycle, and I'm going to change that program. And remember, we were running MM2. So what I can do here is go into the program. We're going to move that from MM2 to sample and put that into the main program. Okay, and then we're going to go and start this again. And what you'll see is that this is going to, you can see that this machine went idle, and it should just take a few seconds. You're going to see that update to the new program. So just note that there's really no, operators don't have to interact with this at all. All you need to do is connect your machine, configure the operation. You can see it just changed to the sample program. And you're tracking all of your historical information. So if you, for example, if you're going to requote a job that you ran in the past, all you have to do is go back into Machine Metrics and find that job, and you'll have all the information required to make sure that you can accurately quote the right cycle time, the right amount of time that it takes to produce those parts. So there's just an example of what this looks like on a modern machine. I want to draw your attention to this other machine. This is a lathe, and we actually had a question that I can answer right here at the same time. Some machines on your shop floor might be 30 years old, and they might not have the ability to pull data right from the PLC. So in those cases, we can install sensors on the machine. Often we'll be getting utilization data and part counts, and that's it. And let's go and look at the data that's being pulled from this machine. A lot less, right? So really all we're pulling is the execution state, so we're active, and a part counter. And in that case, we're not getting operational data from the machine. So you will need operator input in this case. And the real goal here is, depending on your mix of machines, what we find is that slightly more, a majority of machines are modern enough where you can get the operational data from it. And then depending on the layout of your shop, there might be some machines that you'll need a little bit more interaction. So what I want to show next is what that looks like. So if we go to this is the 3-axis mill. This is connected to that FANUC controlled machine. And what we see here is that we're running this sample program, and there's not currently a work order associated with it. So in order to lay out the data so it can be synchronized to your ERP, you'll need that work order number. And that is, in a lot of cases, that might be that minimum piece that's required from the operator. So instead of having to make sure that that operator, at the moment that they're setting up that machine, that they go into your system, they type it all in, they can get the machine running. And then when they have some spare few minutes, they can go in and then add the work order number. So here we'll go into the whoops, let me just refresh this here. So we'll go right into the machine and edit that work order. Okay. So yeah, so we can edit that current work order, and we'll give that, it's actually 1022. So now we have the work order that's attached to that operation, and the data is structured in a way that you have the operation, you have the machine name, you have the when that production run started, when it ended, the work order, everything you need to automate that data flow into your ERP. So I want to show you what this looks like in a machine that doesn't have the work order. So here, let me refresh that so I don't. Essentially, this lathe is just remember, we have just two sensors, one for the part counter and the other for the execution state. This machine is actually idle right now, so this is completely optional. Jordan mentioned that that you do have the ability to categorize downtime. We'll go ahead and do that just to demonstrate this right now. You can categorize that as, let's call it machine maintenance, call it planned maintenance. Okay, so now we know why the machine was down if we can't get it from the machine data itself, and it will be available in the reporting. But we can see that this is not running a program right now, so we can go ahead and start that run. This is that piece that might be required if you have that legacy machine. And we're going to run a new part called a wheel bushing. Okay, so that doesn't already exist. We can go ahead and create it just right here. So really, this could either be a typing in on a keyboard, or it could be just a barcode scan that includes the operation. So we'll go ahead and we'll create it. We'll call it work order 1021, and then we'll create and start that run. We'll put that right into production as opposed to set up. So that's all we need to do. Now, we're running this this work order, this operation, and this is the case of a more manual machine. So going to the this list here, what I want to point out is, okay, now that we have this information from the machine, you can see that we're running that wheel bushing now. Let's go and look at the reporting. So here we have that sample job. I'm going to go and look at the operation report. So this operation report, what this does is it gives you that overview of when this sample operation ran. And I can see that I ran on this mill and also the lathe. And let's drill into the mill to give us more data just on that. And now we have a history of every production run, and we can see trends in cycle times. We have our expected cycle and our actual cycle time. So is it getting better or worse? If we're tracking it, rejections and downtime is all available here. So you have a good sense when you're running this job again, for example, you can go right into this report and identify some of the issues that you had in the past and really do a better job quoting and scheduling. So that's just in as a quick review of the production side. What I wanted to also kind of point out is some of the capabilities that you have by building workflows around this machine data. So what we see here is so on this mill, what I want to demonstrate, and let's pull this up here. We have a workflow set up. I'm going to go back into the workflows, so that when your feed rate override is below 100, we're going to send a notification to myself and also a message to the operator. It's really easy to configure. Any workflow can be done by just giving it the alarm native code, and then the action. We have multiple actions. An idea of the various triggers that can occur, and then actions could be notification either through text, an operator message. It could be a webhook into a third-party system. That's how we integrate into other systems. And let's go actually see this in action. So I'm going to go back into this this machine here, and I notice that our override is set pretty high. Let's put that into a low override state. Okay, and now what that will do is it will we could see this right in the machine list here. We're going to go into an alarm state. And that will produce a message. So you can see right here, this popped up, right? So feed override has been below 100 for too long. Please reset. And I also received the message on my phone. So it's good to know, like if an operator accidentally left the feed override in a low state, this is a good way to really communicate that we should put this back to 100. So there's an example of a workflow. Another one that could be really useful is you could set up these configurable workflows to basically call action to an issue that might occur. So this is really enhancing communication. So in this case, let's go ahead and call an engineer. Why is it that my override was too low? And then the engineer is notified via text, and they can come over and really see what the problem might be. So that's just like a quick review of a couple other things I wanted to point out just in the application. We won't go into the details, but it's really broken up into your machines, to your reports. So we have numerous out-of-the-box reports and the ability to build your own, all of your production information, and then your automations. So one area that I wanted to drill into, and I think that'll be enough. We can open up the questions. Is really a pretty common report that we see, which is this downtime report. So if we go look at a couple of weeks of time, this really allows you to drill in to see where problems might be occurred. And now you can set this up, based on alarms, or it could be based on downtime that's categorized by the operator. And remember that this is not required. If you really want to know where your bottlenecks are, you might want to ask your operators to classify downtime for a period of time. But as long as you're continuing to use this data to improve processes, if you're not, there's really no point in having your operators take the time to classify downtime. So it's really up to what you're looking to achieve. But let's drill into this a bit, and we can see we've got this bearing issue that I want to drill into. So if I click into this, we can see that full view to see like what job was running, what those issues were, where my alarms were, and we can really really start to understand where these why these problems occur, and then apply some continuous improvements to make sure that these problems don't happen again, or that time is reduced. So that's just in a nutshell. Machine metrics really gives you that ability with right out of the box. We can easily connect to machines of all different types. We can that data is automatically mapped to what you see here, this data structure, so that you can run these analytics. You can monitor your production without any operator input. You can build workflows, notifications based on certain machine conditions, and this can be pretty dramatic in terms of improving your machine uptime. And also really driving data into other systems to really connect your entire factory floor with real-time machine data in an automated fashion. So with that, we do have a few minutes for questions. I know there's a few that came in, so I'm going to just let's see. I'm going to stop my share here and open that up to questions. And Brent, I don't know if I should maybe start asking the questions that I see right now, or
sure. Let me thank you, Bill. Let me just make a quick reminder to our live audience that right now is the opportunity to ask questions. Please type them into the questions panel, and we'll do our best to get to them. As Bill mentioned, we do have a couple of questions in the queue. We can take this wherever you'd like to start, Bill. I'll just read the top one if that's all right with you. What role does MT Connect play in interconnectivity with the shop floor?
Yeah, so MT Connect is a standard protocol that really started in CNC machining. That does make it easy to capture data from machines. It often does require upgrades for your machine tool, but if you're able to get MT Connect on your machine, you should, because then that makes the data collection very easy. There are certain machine types, for example, especially in North America, there's a large percentage of machines that use FANUC-based controllers, and for those we have our own way to connect directly to those machines. So you wouldn't need to add on MT Connect for some of these more standard controls, but machine types such as like Mazak, Okuma, and there's a bunch of others, that would be the best way to get data from the machine.
And then next question, are you at liberty to talk about what microcontroller your device is based on?
Sure. So our edge device is just a really simple, lightweight x86 computer. It's very inexpensive. It doesn't take that much to run our edge software. There is some advanced analytics that we run into some tool monitoring capabilities that requires a little bit more horsepower. But really, it's any x86 device. And I should add that we can also run on your own hardware. So it's not you're not restricted to buying the device that we provide. It can run on a server or some hardware that you have laying around. We call that virtual edge.
All right. Next question: what are some major PLC systems that your system or your device is compatible with, or do you do an initial site survey before deciding that?
Yeah, so we ask our customers for what we call a factory assessment. So let us know what your machine types are, the control, the PLC, the model, and that helps us determine what the connectivity method is. For most modern PLCs, they're going to support some standard protocol. So it could be OPC UA, Ethernet IP, Modbus. They might have MQTT. There's various ways that you can get data from a PLC, and we built all that into our edge software.
Bill, maybe you can just talk a little bit about the effort it takes to get everything set up to fully automate production monitoring. What does the timing and effort look like?
So so the effort, it could be pretty straightforward for the true automated production monitoring. You want to understand from the machine data. The basics are, so a data tag that indicates if the machine is running. Then you want to know the part counts. So a lot of these machine controls, they have a counter that increments when the cycle is complete. So those are required. And that third one really is that operational name. Now, it could be just a number, but it's better if it has some kind of context. So you could show, for example, it might be like what we showed an example. There might be an operation number, a part number, or a name that could be pulled right from the data. So once you identify those data items, it's just a matter of a couple button clicks, and you'll have that information streaming into Machine Metrics and populating your all of that production information. So it could be a matter. Often the slowest thing is making sure that your machines are networked. So you want your machines to be on a network so you can communicate to them, and that can be sometimes the slowest piece of getting this going.
Sort of related, would you be willing to talk about the installation process? Do customers need to pay to have someone install those devices? How does this work?
Yeah, so a lot of our customers, in fact, 80% install Machine Metrics on their own. It's really built to be very simple. You do have the ability to send a technician from Machine Metrics on site if that's what you prefer, but it is designed to be simple. The implementation, essentially, we haven't gone into that part of it, but it's you activate the edge device just like it's your home IoT device. Then essentially you add your machine and you give it the IP address, as long as that machine's on the network, the type of connectivity method, FANUC, NT-Connect, OPC UA, and if it's a CNC machine, then that data is automatically mapped, and there's nothing more that you need to do.
Looks like we have a couple more questions in the queue here. There's kind of a two-parter about ERP systems. So a lot of people think of ERP systems as finance and planning tools. Can you talk a little bit about how machine data would be applicable in that solution? Let's just start there.
Yeah, so really, when we talk about ERP in like a machine shop, we're really talking about MES and ERP together. That's commonly how these services are delivered. And the MES part really is about monitoring your production. So it has what are called labor tickets. So whenever there's a job that's been run as by a particular operator, a particular resource or machine, and there's an operation and a work order. So that information is used to help in your production planning, to understand when your product is going to be delivered to your customer, all the different steps along the way. And the way that the machine data can be really powerful is, one, you can automate that data flow. We talked about that. But the other is that when you're using when you're just going off of, say, a simulation, or what your CAM software says that it'll take to produce a part, you're missing a lot of the pieces. You're missing how much downtime there might be for a tool change, for changeovers. You might have issues with certain operations that take longer than what's been simulated. So having that real data will help you provide more accurate quoting, will help you understand how long it'll take to produce a series of or a lot of parts. So it can be pretty powerful. And you don't need that integration to see value. By understanding how to find that data in Machine Metrics, and it's really easily surfaceable, just use that information to validate your future quoting for in a job shop environment. But that integration does provide that the automated data flow and reduces the amount of manual data entry, for those customers that do get to that point. Not all do. Not all go through that effort to actually, take that last piece to connect machine data to their MES.
Why would it be important, or why could it be beneficial to interface with an ERP system? And which ERP systems does Machine Metrics work well with?
Well, I think I answered the first part of the question. Why would you interface with it? That full integration really is to reduce that data input and the potential for errors. In terms of the different ERP MES systems that we communicate with, the interesting thing in this industry is that there's a lot. There's a lot of different systems out there, and our goal has been to structure the data so that it's very simple. So that last piece, there's, depending on the ERP, there's some that will support out of the box, and there's others that require this small integration, this step that often you have an expert on staff, or there's another system integrator that will connect that last piece.
All right, we do have a couple of more questions rolling in here. Let's see. How do you specify defects in the production process? Do you use expert knowledge for process anomalies or use some types of quality control charts?
Yeah, so we're not a quality system directly, but we are able to identify, in some cases when there's scrap parts. An example for that would be, we have a customer. There's a case study on our website called BC Machining, and they make these tourniquet handles. And what happens quite frequently is that they're pushing these out, every couple minutes. Occasionally there's a defect in a tool that can cause that finishing operation to fail, and it's often not caught until maybe 25 pieces have been produced. So by looking at that data, the actual cutting data, you can identify at the moment that tool cracks, we can identify that and prevent those scrap issues. So we help quality, but we're not a quality system. We're not managing all of your dimensional data. There's other systems that are great at that, that we're designed to integrate with.
Mark wants to know, have you connected to Netsuite?
We have connected to Netsuite and and a number of other ERP systems. Netsuite is another cloud-based system, so it's easier than some.
Scott is asking if there's anything to share on the government or DoD side, any activities pending?
Activities pending. I mean, we do work with government contractors, and so I'm not exactly sure what that is. I mean, if you're talking about some of the security protocols that we need to ensure that we meet, we are ISO 27001 certified, and that means that we've had to go through all of the audits, all of the processes required to be able to serve government agencies, and we also work with a number of ITAR companies.
All right, that appears to be it for the question. We have one comment just saying, thank you, very good presentation. I think that's probably a good place to leave it off. So yeah, let's call it. And I just want to end with saying thank you to you, Bill, and the entire Machine Metrics team for making this webinar possible. I also want to thank Jordan, as well as everyone who's listening in. You guys should receive an email with a link to the recording soon. And with that, that does conclude today's presentation. On behalf of Modern Machine Shop, I'm Brent Donaldson. Thank you so much for your time and enjoy the rest of your day.
Great, thank you.